Good morning and welcome, students. Today we will discuss a topic, Bohr's model of an atom, from the chapter Structure of the Atom. Class 9, Chapter 4, Structure of the Atom. As you do academy education, please like, share and subscribe the channel. Don't forget to click the bell icon so that I can send you notification for every video update. Now, structure of the atom. Contents. First, Bohr's model. Second, postulates of Bohr's model. Third, limitation of Bohr's model. Fourth, discovery of neutron. Fifth, mass of a neutron. Sixth, charge of a neutron. Seventh, atomic number and mass number. 8. What is atomic number? Ninth, what is mass number? 10th, how do you find the atomic number and mass number? 11th, what is the relation between atomic number and mass number? 12. Examples of atomic number. 13. Atomic number, orbital, energy labels. And 14th, the complete nuclear symbol. Now the first topic, Bohr's model of an atom. Bohr's model of an atom. After the limitation of Rutherford's models, Niels Bohr proposed a modified model of the atom in 1913. The main postulates of Bohr's model of atomic structure are as follows. First of all, Bohr's model descriptions of the structure of atom, especially that of hydrogen, proposed 1913 by the Danish physicist Niels Bohr. The Bohr model of the atom, a radical departure from earlier classical descriptions, was the first that incorporated quantum theory and was the predecessor of wholly quantum mechanical models. The Bohr model and all of its successors describe the properties of atomic electrons in terms of a set of allowed, means possible values. Atoms absorb or emit radiation only when the electrons appropriately jump between allowed or stationary states. Direct experimental evidence for the existence of such discrete states was obtained 1914 by the German-born physicist James Franck and Gustav HAZRA. Student, please attention all students. Watch the video carefully and repeatedly to understand properly. Stay tuned for all video updates. Please comment in the comment box for all your doubts in this chapter. I will make video for all questions raised by students. Please don't skip the video, otherwise you will miss the important part. All the topics are explained thoroughly, very carefully and clearly. Still, if you any single student is unable to understand any part of the video, please let me know in the comment box. To determine the maximum number of electrons that can occupy an energy level, use the formula. So this formula represented by 2n square. Here n equals the number of the energy level. Level 1 means this is the structure of an atom. Level 1, it's contain 2 electrons. So the formula of 2n square, according to the 2n square, it's 2 into first cell, it's 1, so that is 1 square. So that's why the first cell contain 2 electrons. Level 2 means energy level 2. Second orbit, it's contained 8 electrons. So according to the formula 2n square, 2 into 2 square. So 2 into 2 square means 2 into 4 is equal to 8. Level 3, energy level, it's contained 18 electrons, and level 4 is equal to 32 electrons. Now the postulates of Bohr's model of an atom. Electrons revolve around the nucleus in a definite circular path called orbit or cells of an atom. Each orbit is associated with a definite amount of energy. Hence, they are also known as energy levels. This N is energy levels. Third, cells or orbit of the atoms are designed as KLMN. They represent different orbits, that is N, means energy level, it's 1, 2, 3, 4 respectively. The number of electrons in each orbit is governed by the formula 2n square. So when n is equal to 1, that is k cell, 2n square is equal to 2 into 1 square is equal to 2 electrons. When n is equal to 2, that is L cell, 2n square again, 2 into 2 square is equal to 8 electrons. When n is equal to 3, that is M cell, again the formula 2n square, 2 into 3 square is equal to 18 electrons. When n is equal to 4, that is N cell, the same formula 2n square, 2 into 4 square is equal to 32 electrons. The electrons in an atom move from a lower energy level to a higher energy level by gaining the required energy, and the electron moves from a higher energy level to lower energy level by losing energy. Now, the limitation of Bohr's model of an atom. Bohr's model of an atom failed to explain the Zeeman effect of magnetic field of the spectra of atoms. It also failed to explain the Stark effect of electric field on the spectra of atoms. It violates the Heisenberg uncertainty principle. It could not explain the spectra obtained from larger atoms. Now the next topic, it's discovery of neutron. Another subatomic particle which was discovered in 1932 by James Chadwick was found to be neutral and had a mass nearly equal to that of a proton. It was termed as neutron. Almost all the atoms constitute neutrons except hydrogen. Generally, neutron is represented by small n. This subatomic part is not present in hydrogen atom. Now the next is mass of a neutron. The relative mass of neutron is 1U. The mass of neutron is equal to the mass of proton. The absolute mass of neutron is 1.6 into 10 to the power minus 24. Now the charge of a neutron. Neutron has no charge. It is electrically neutral. Atomic mass of carbon is equal to mass of 6 protons plus mass of 6 neutrons. So that's why 6 plus 6 is equal to 12U. Now the next topic, atomic number and mass number. The first one is atomic number. First of all, atomic number is represented by capital Z. Rutherford established the presence of positive charge on the nucleus of an atom. It was due to the presence of protons in the nucleus. The number of positive charges present in the nucleus of an atom is known its atomic number. I am repeating again. The number of positive charges present in the nucleus of an atom is known as its atomic number. Since the atom is electrically neutral, atomic number capital Z is equal to number of protons is equal to number of electrons. Now the mass number or atomic number, this mass number or atomic number, it's represented by capital A. It is the sum of number of protons and neutrons present in the nucleus of an atom. So what is the mass number or atomic mass? It is the sum of number of protons and neutrons present in the nucleus of an atom. Mass number, it's represented by capital A, is equal to atomic number plus number of neutron. So atomic number means number of protons plus number of neutrons. Number of electrons plus number of neutrons. Therefore, number of neutron is equal to mass number minus atomic number. Now, what is atomic number? The total number of protons in the nucleus of an atom gives us the atomic number of that atom. It is represented with the letter Z. All the atoms of a particular element have the same number of protons and hence the same atomic number. Atoms of different elements have different atomic numbers. For example, all carbon atoms have the atomic number of 6, whereas all atoms of oxygen have 8 protons in their nucleus. The same, what is mass number? The number of protons and neutrons combined to give us the mass number of an atom. It is represented using the letter A. As both protons and neutrons are present in the nucleus of an atom, they are together called nucleons. For examples, an atom of carbon has 6 protons and 6 neutrons. Thus, its mass number is 12. While the number of protons remains the same in all atoms of an element, the number of neutrons can vary. Thus, atoms of the same element can have different mass numbers and these are called isotopes. Isotopes, the same elements have same atomic number but the different mass number, it's called isotopes. The weight of an electron is almost negligible. Thus, the atomic mass of an atom is almost the same as its mass number. How do you find the atomic number and mass number? Together, The number of protons and the number of neutrons determine an element's mass number. So that's mass number is equal to protons plus neutrons. Number of protons plus number of neutrons. If you want to calculate how many neutrons of an atom has, you can simply subtract the number of protons or atomic number from the mass number. What is the relation between atomic number and mass number? The mass number of an atom is equal to the number of protons plus and number of neutrons that it contains. In other words, the number of neutrons in any atom is its mass number minus its atomic number. Now, this is the electron cells of hydrogen. This is the isotopes. Now, look at here. Hydrogen, mass number 1. It's called protium. It's called protium. Second, hydrogen 2. This is called deuterium. Its mass number 2. Means the first one is atomic number and mass number is same 1 1. Second one, mass number is same, atomic number is same 1 but the mass number 2. So it's called deuterium. Third, the hydrogen 3 tritium. Its mass number 3 but the atomic number 1. Examples of atomic number. The atomic number of an atom is equal to the number of protons in the nucleus of an atom or the number of electrons in an electrically neutral atom. Atomic number is equal to number of protons. For examples, in a sodium atom, there are 11 electrons and 11 protons. Thus, the atomic number of sodium atom is equal to number of electrons is equal to number of protons is equal to 11. Atomic number, orbital energy levels. The most common way of showing the arrangement of electrons in an atom is to draw diagrams like those shown in the diagram. The complete nuclear symbol. The complete nuclear symbol contains the symbol for the element and numbers that relate to the number of protons and neutrons in that particular nucleus. To write a complete nuclear symbol, the mass number is placed at the upper left of the chemical symbol and the atomic number is placed at the lower left of the symbol. The complete nuclear symbol for helium-4 is drawn below. Now look at here. This is the chemical symbol of helium or nuclear symbol of helium. This is also called isotopes. Now the mass number, it's a upper level and the atomic number always is lower left. Okay, upper left and lower left. Thank you all students for watching the video carefully and repeatedly to understand properly. Stay tuned for all video updates. Please comment for your doubtful questions in the comment box. I will make video for all questions raised by students. Please don't skip the video else you will miss the important part. Please like, share and subscribe the video of the channel Agito Education. Don't forget to click the bell icon so that I can send you an intimation for my every latest video.